Aircraft flies an altitude of 3,500 feet from A to B, elevation of 700 feet, QNH of 1015 hectopascal. The airport B is at elevation of 1120 feet, QNH of which is at 992. The altimeter subscale is not changed. The altimeter subscale is not changed. What will aircraft indicate when it arrives at B? Very simple question. So there are two places given to you. Let's draw them. Place A is here. Your aircraft is at the airport, let's say, or in the air if you want that. Next, for A, so elevation of A is 700 feet, QNH 1015. QNH 1015. QNH is 1015 and elevation is 700 feet. Elevation is 700 feet, right? So let's draw that. Elevation is 700. Next point, altitude 3,500 feet. All altitudes are measured from QNH. All altitudes are measured from QNH or mean sea level. So that is 3,500 feet. 3,500 feet. Now when it goes to place B, the information is elevation 1120. So QNH is given. Elevation of that plane is, let's say, 1120. Next, QNH is 992. QNH is 992. What will the aircraft altimeter show? The height. We are told to find height. So we have to find this particular height. Height from the airport. So this is wrong actually. Elevation is 1120. Elevation is 1120 and QNH is 992. That's fine. Okay. So look at this problem. We are beginning from point A. We are going towards point B. Okay. So at point A, we have set our altimeter. We have set our altimeter to 1015 to 1015. And when we reach place B, still the aircraft altimeter has a subscale of, it still has the same subscale of 1015. It is the duty of the pilot to reset his altimeter setting as he goes from place A to place B. It's the prime duty. But if you don't do that, your altimeter will keep on showing the altitude or vertical distance from the pressure datum that you have put in this subscale. So if you have put 1015, all your vertical distance or altitude will start from 1015 pressure level. Now in this case, the 1015 pressure level will be somewhere here, 1015, and it will show vertical distance from 1015. So what will it show when aircraft is here? It will show from 1015. What will it show? It will show 3,500 feet, the same as before. So it will show 3,500 feet. right? It will show 3500 feet from 1015. In order to get correct altitude indication at place B, it's the duty of the pilot to change 1015 and put a new input of 992. But if you don't do that, if the pilot doesn't do that, he will get indication from 1015 level. So remember that. Now, this diagram is not useful to us to solve the question because we want to find the height of aeroplane from the airport, height of aeroplane from the airport, above the airport. Now to get this height, we will have to do some calculations. Now we know this big is 3500, okay? This is 3500, entire thing. Out of this 3500, this much is your height. You agree? This much is your height. Now this entire 3500 is made of three parts. It is made of 3500 is made of three parts. First part is this much height. Okay. Second part, it is made of this elevation. And the third part, it is made of only this small part, which is this. Okay. Now let's find this small part. How to find that? How to find the height difference between these two levels? Let's find the pressure difference. The pressure difference is how much? I will write here. The pressure difference is 1015 minus 992. So it is how much? 23 millibars. That will be a height difference of how much? 1 millibar is 30 feet. So 23 into 30 is how much? So when you multiply that, 3 3s are 9, 3 2s are 6, 690 feet. So this much is 690 feet. 690 feet. So I will write that here, 690. So let's substitute the value. 3500 equals to height, elevation 101120 plus 690. So height will be equal to 3500 minus this 0, 9 plus 2, 11, 1810. So height is equal to 1690 feet. Height equals to 1690 feet. Okay. It is equal to 1690 feet. So the correct option is option number C. So how did we start doing this sum? Draw the sum, basic aeroplane, your airport QFE, QNH level, right? Label that diagram. You have 1015 in your altimeter. When you go to B, you have the same setting in your altimeter in your plane. Again, same draw elevation, draw airport, draw QNH level. Now the question states explicitly that the subscale is not changed. So we have to also draw 1015 here, 1015 level here. And we will get 3500 from aeroplane to 1015 level made of height, elevation and 690 feet obtained like this, the difference between two pressure levels. Substitute the values and you get height of that aircraft above the airport, location B, location B, which is answer 1690 feet. Let's go to question 23. The atmospheric pressure at flight level 70 in a standard plus 10 atmosphere is how much? Now we have to find atmospheric pressure at flight level 70 or 7000 feet. Now pressure at mean sea level is 1013. We know the rate of fall of pressure, rate of fall in pressure is equal to 1 millibar every 30 feet. So we have to find the rate of fall of pressure starting from mean sea level up to flight level 70. So I know mean sea level pressure is 1013. We must know how much the rate will fall from mean sea level up to flight level 70. So that how much it will fall. So x equals to 7000 is the difference between them. So x equals to 7000 divided by 30 is how much? 233 millibars. 233 millibars. So that means rate of fall is 233 millibars. 233 millibars. So pressure at flight level 70 is less than 1013. 1013 minus 233. So pressure existing at flight level 70 will be 780 millibars. 780 millibars. Okay. So this is how you do it. 780 millibars. Option A will be the correct option. Question 24. On board aircraft, the altitude is measured from what to what on board. So on board aircraft, your altitude indicated by altimeter will depend on the pressure setting that you put. Okay, QNH, QFE, 1013, whatever. So the correct option will be option C, pressure altitude. Okay, density altitude is calculated, right? It's not shown directly. Standard altitude, there is no such thing as standard altitude. We have standard pressure setting, but not standard altitude. So question 25. QNH 999, what is the pressure altitude at an elevation of 25,000? So simple. This is your airport. We have to, and elevation of this airport is 25,000 feet. 25,000 feet. And we have to find pressure altitude. Pressure altitude will be measured from standard pressure setting 1013. So that will be equal to how much? We have to find. So we have to find this pressure altitude, which will be made of 25,000 plus x plus this x. So total pressure altitude we have to find. So let's find x. X equals to change in height x equals to h, that is your height. Height between the two pressure levels, right? Height between two pressure levels. So this is how much 1013 minus 999 is 14 millibars. 14 millibar is equal to height difference of 14 into 30, 420. 420 feet. This is 420. So now total pressure altitude will be equal to 25,000 plus 420, which is 25,420 feet. So correct option will be option Bravo, 25,420 feet. Here we have taken 1 millibar to be equal to 30 feet. You also, the correct option or the correct way, the accurate value is actually 27. So 1 millibar is 27 feet. So 14 millibar will be how much? So 14 into 27. But for simplification, I have taken instead of 27, 30. So if you take 27, you will definitely get 25,400. Otherwise, I have gotten 420. So the closest option is that. Let's go to question 26. Pressure altitude is given to you. Elevation is given to you. You have to find Q and H. Now this is the reverse of the previous sum. This is your airport. This is your Q and H. And this is your standard pressure setting 1013. Now pressure altitude is more than your elevation. That's why I know that the pressures, that's why I know, this is how I know that QNH is less than standard pressure setting, because if pressure altitude which is obtained from 1013 is more than elevation, so that means standard pressure setting is going to be more than QNH. So means higher the altitude, in comparison, higher the altitude, higher will be the atmospheric pressure and lower will be this QNH. So this is higher than this. So this pressure will be higher than this. That's why 1013 I have drawn below QNH and QNH will be less than 1013. So elevation is 22,000 and pressure altitude is 22,800. So the difference, height difference between them is how much? 800 feet. So 800 feet height difference will give you a pressure difference of how much? It will give you this pressure difference of how much? 800 divided by 30, which is equal to how much? 800 divided by 30, which is 27 feet, which is 27 feet. So QNH will be less than 1013 by 27 feet, which is equal to 986 millibars. 986 millibars. Option Bravo. Again, here they must have taken 27. That's why 985. Otherwise, 30. You get 986. Difference of 1. Ignore it. So 986 millibar. So just the trick is to draw the diagram. Elevation is between airport and QNH. I have repeated this multiple times in different videos. Pressure altitude measured from 1013, so that line, and we are told to find QNH. So this QNH level can be found from this pressure datum and this height difference. Okay, pressure difference of 27 millibar. 27 millibar. Okay, height difference we have 22,800 minus 22,000. So this height difference I know is 800 feet and pressure difference is 27 millibar. Let's go to question 27. Pressure altitude is given, QNH is given, what is elevation? So let's draw the diagram again. Airport, QNH, standard pressure setting 1013. So pressure altitude is 3700. QNH is 1000. Now what is elevation? Okay, to find elevation, out of this big part we will have to subtract this part. So let's calculate that. That will be equal to how much? A height difference of how much? So here you go. Pressure difference is 1013 minus 1000, 13 millibars. That will be height difference of 13 into 30, 390 feet. So this is 390. So your elevation will be equal to pressure altitude, this big value, minus this small value of 390. Let's take 400 is equal to 3,300 feet. So correct option is option A, 3,310. Ignore that. So what is field elevation? It is 3,300 feet. Okay, correct option is option A. Question 28. Takeoff and landing performance must be calculated based on what? So before every flight, we always do a proper flight planning. What will be the conditions of atmosphere when we take off? What are the facilities available at the airport? What is the status of your aircraft? How many passengers? How much fuel? conditions during cruise, the weather, the speed you're going to fly at, what are the communication frequencies are expected to be used, any NOTAMs, any NOTAMs, any pirates, okay, any valuable reports from the company, the conditions at your destination. So this all big planning should be done before your every flight, whether you are a student pilot, airline pilot, anything. So this flight planning consists of a proper detailed planning for your takeoff airport. So you take into consideration the density, altitude, how much takeoff distance you will need, landing distance, your rate of flight, etc. Same thing for your landing airport, the landing roll that you will need, the rate of flying in that event of missed approach you will need at your destination, etc. etc. So all these calculations that you do related to aircraft performance, engine performance, so those are based on two things. Those are based on two things. For takeoff, when you are taking off from an airport, when you reach that airport, okay, you have current weather, current updated information available to you. Okay, all the met reports are current. They are current. The reports about weather are current. Winds, temperature, dew point, all your calculations will be up to date. Okay, because you are going to just after your flight planning, you will start your plane and take off. Okay, so this reports that you have are going to be valid for next 1 hour, 2 hours. So always for calculation of takeoff performance, you make use of values which are actual. Okay, which are actual. Values that exist right now, right? So in case of takeoff, you make use of actual values. In this case, actual temperatures. In this case, actual temperatures. And at the same place, when you are planning for your takeoff, you will also plan for your landing conditions. Now, when you are going to land, you will land after 1 hour, 2 hour, 3 hours. So when you are landing after so many hours, at, at, at the present moment of time, you won't be having with you information which is current or updated. Okay. All you will have is forecast. You will have forecast temperature. Okay, you don't know after 2 3 hours what actual temperature will be at the airport of landing, but you can have an estimate, you can have a prediction, you can have a forecast that this is what is expected over there after 3 hours. So for takeoff performance calculations, you use actual values. For landing destination aerodrome, you use values which are forecasted. Okay, so the correct option is, the options here are not correct, but the correct option will be the option which will contain actual temperature and forecast temperature, and actual temperature and forecast temperature, because for takeoff you need actual, for landing you need forecast, and during your flight when you finish your cruise phase of flight and now you start your descent, or even before just descent, you will get updated current information from that landing airport ATC tower or ATIS frequency. Okay, automatic terminal information service. When you hear that frequency, you will get the current weather report at that airport. Okay, that will be current. But just at takeoff airport, when you just do a planning, okay, to get an idea of what to expect after 3 hours, you get forecast values or forecast temperatures. Question 29. If outside air temperature at an altitude of 5,000 feet is 10 degrees Celsius, what is the temperature deviation? So outside air temperature or current temperature is 10 degrees Celsius. Altitude is how much? 5,000 feet. ISA temperature at 5,000 feet is 5 degrees Celsius. So we are asked ISA temperature deviation. So ISA deviation equals to outside air temperature, current temperature minus ISA. Outside temperature is 10, ISA is 5. So option Bravo, plus 5 degrees Celsius or plus 4.9. So outside temperature is 10. ISA says at 5,000 feet you must have 5 degrees Celsius temperature. but the outside temperature is greater than that, more than 5, that means it is more than 5 or warmer than 5 degrees Celsius. So 5 degrees Celsius plus sign. Okay. So this is one simple question. Okay. It can get asked in exam. Now I want to do after this, we have left one important sum, which is question 21. Okay. This is the last sum. Aircraft is in level flight at flight level 100 over a mountain range. Mountain range is 2400 meters above mean sea level. QNH is 998. What is terrain clearance? Simple. So let's say this is your mountain. Mountain is at mean sea level, and mean sea level QNH is 998. Now the mountain is how much high from mean sea level? It is 2400 meters. 2400 meter. To convert that into feet, what is the formula? 1 meter is 3.28 feet. So 2400 meter will be equal to how much? So it will be equal to 2400 into 3.28, which is equal to 7872 feet. Very high mountain above mean sea level. Then you have aircraft which is flying at this over this mountain, and that aircraft is flying at a pressure level 1013, above this pressure level of 1013, flight level 100, 10,000 feet. Now you are told to find the terrain clearance, the difference between the height difference between your aircraft and the mountain peak. Okay, you have to find that. Now to find that, you will have to subtract some values from the biggest value. Now this much you know is 10,000. Okay, this entire thing is 10,000. Now this 10,000 is made of three parts. First, it is made of, I will write it here. It is made of x. We have to find this x, which is terrain clearance, this much. So let's write it x. The second part is this much. After this, this, which is 7872. The third part is this. Okay, which is the height difference between these two pressure levels. So let's find that height difference equals to how much? Now pressure difference is how much? 1013 minus 998. So it is equal to 15 millibars. That is equal to a height difference of how much? 15 into 30, 450 feet. So this much is 450. This much is 450. So let's write that over there. 450. Now 10,000 equals to x plus 2 322. So x will be equal to, terrain clearance will be 10,000 minus 8322. So 10,000 minus 8322, which is 1678. So terrain clearance is 1678 feet. So the height difference between your aircraft and mountain is 1678 feet. Okay. So the correct option will be option A, 1681 or 1678. The closest option is option A. So you have to remember these points very well. Okay, this is how you solve the sum. Draw the mountain, label it. Once you have done that part, 50% job is done. Stick to the basics, stick to the formulae. That's it. So you get this answer. So this is how you do this sum. Okay. With this we will with this sum we will stop here. We will do the next sums of this chapter in the next video. So don't miss that video. And I hope you have liked this lecture. You have understood it well. Keep practicing, keep learning, keep watching this video as many times as possible. till you get confidence, till you are very proficient in it, and give any altimetry sum, you will be able to do that. So that level of excellency you must strive for. Hit the like button if you like this video, subscribe to this channel, get updates on time, and also share this video with everyone, with all your friends. It will mean a lot to me. Thank you. All the best.